Okay, 1.2 is all about transformations of linear and absolute value functions. So it's all still about transformations. We're going to stay on transformations for a while. And with that, I want to show you this. This is on your Schoology page right up at the top above the Chapter 1 folder. Okay. Again, this cheat sheet is going to be extremely helpful. Okay. All right. Today, when we're going through this, I want you to be thinking about these graphs. F of x plus k, f of x minus h inside those parentheses, and negative f of x. I want you to be thinking about that. Okay? Let's scroll down. Let's get these. Let's go right here. Compare the graph of each function to the graph of its parent function, f. Use a graphing calculator to verify the answers are correct. We're not going to use that. Okay, we're just going to focus up here. What is the parent function of these three? Well, it's this function right here, right? Y equals the square root of x. Okay, that's the parent function. It's a square root function. So, how does y equal the square root of x minus 4? How does that move from the parent function? Well, we go back to the sheet. Okay, we have our function minus 4. Which one has our function and then minus a number? And it's right here. We have our function f of x, or the square root of x. And then we have minus 4, or minus k. And it moves the function k units down. So, a here, in this case, y equals the square root of x minus 4, moves it down 4 units. How about b, where we have our function y equals the square root of x plus 4, and that plus 4 is under the square root. Okay, so we have our function y equals the square root of x plus 4. Now I want to come back to this page, okay? And I want you to try to guess how that function is going to move by looking at this sheet. Okay? So if you need to, pause the video. I'm going to point it out right now. It's this one right here. It's a horizontal translation to the left. Okay, where we have our function in parentheses, where it's the function of the whole thing, x plus h, and it moves it h units to the left. Well, we have x plus 4, so how does that move it? Well, it moves it 4 units left. Okay, and then we have y equals the negative square root of x. Take a look here. We already see that negative out in front of our entire function. It's right here. Okay, that's a reflection on the x-axis. So that's what we're going to write. Reflection over x-axis. Okay, or flips it over that x-axis. All right, parts D, E, and F. Parts D, E, and F down here. What is our parent function? Well, they all have that squared. That's our quadratic function, x squared. That's what we'll be working with in parts D, E, and F. So, this first one, we have y equals x squared plus 1. That plus 1 is at the end. Looking at our cheat sheet here, x plus 1, our function plus 1. How does that move it? Everyone should look right here and go, oh, that moves it up. Up, how many? Up 1 unit. Okay, so up 1 unit. Part E, we have that function inside the parentheses, x minus 1. Go back to our cheat sheet. This one should be easier to see. X minus 1 looks like we're moving to the right 1 unit. then we have that negative x squared. What does that do? It's a reflection. We already had that one. Over the x-axis. Okay. Moving on. We'll jump down here to the extra practice. Okay. Let me give you okay, I wanted to make sure we see this one actually. What we want to do is write a function g. Okay, so instead of f of x, we're just going to have g of x. There's really no big surprise there. So write a function g. Well, instead of f of x, we're just going to write g of x equals something. Who represents the indicated transformation of the graph f? Use a graph calculator, check your answer, which we will actually do here. F of x equals 1/3 x, or the absolute value of 1/3 x. We want to move that 2 units to the left. So we want to write a new function where we translate it 2 units to the left. So 2 units to the left. We want a horizontal translation. We want to go left, right here. We have f of x plus h inside the parentheses. Okay. So we're going 2 units to the left. Well, back here we should go 1/3 x plus 2 inside the absolute value. Okay. Now I want to show you this function. Okay. So here's my absolute value. There's what we started with. We want to go 2 units to the left. Okay. So let me pull up my keyboard here. Oh, give me 1 second, sorry. Okay, there we go. Now let's type in that new function. Y equals y equals the absolute value of 1/3 x plus 2 absolute value. Okay, look what happens. That's not to the left 2. If we were to the left 2, we'd have our function right here. We'd be going off to the side, right? So that's not necessarily the right answer. If we have a fraction, like we do with our function y equals 1/3 x, we need to match that function. So it's still plus 2, but it's divided by 3. And look how that changes. So if we have a fraction 1/3 in front of our function x, to move it 2 units to the left, we need to add 2/3, which I know is a tad confusing. Okay, but if I go back and I type in like 1/8, let's just say 1/8 x, and I want to move that 2 units to the right, or 2 units to the left, sorry, we're going to say plus 2/8, right? Or let's go 1/2. We're going to have 2/2, or plus 1. That'll move it to the left 2. Okay. So the correct answer isn't plus 2, it's plus 2/3. There is our final answer. Good news on this next one. It's pretty straightforward. We have our function y equals the negative absolute value of x plus 9 minus 1, and we want to move that 6 units down. Okay, so let's look for our down movement. Down, down. Well, it's right here. F of x minus k, so our function minus k moves it k units down. Well, we have minus 1 already. We want to go 6 units down further than minus 1. So our new function, g of x, is going to equal the negative absolute value of x plus 9. Nothing changed there. Okay, we want to go 6 units out from that already minus 1. We're going to be at minus 7. the last one, f of x equals negative 2x plus 2. We want to go down 7 units from that plus 2, so we're going to be at g of x. Nothing changed for that negative 2x, so that's just going to stay the same. Plus 2 minus 7, we're going to be at minus 5. Okay. Moving on. Same stuff. Okay, we want to reflect this function over the x-axis. Take a look. Reflection. Let's find the word reflection. Reflection, reflection, reflection. Okay, right there. Boom. X-axis. We have that negative function. So, we just want to change that whole function into a negative. So we want g of x equals negative 1/2 x plus 8. There's your final answer. Reflection in the y-axis. Let's take a look here. The y-axis. Ooh, the negative only affects the x. It only affects the x, not the entire function. The negative is not way out in front. The negative is only on the x. So what do we have here? We have g of x equals 4 plus the absolute value of negative x plus 1. That's all it is. F of x equals negative 5x. We want a vertical shrink by a factor of 1/5. So go to our cheat sheet. Vertical shrink. We'll find vertical, find the word shrink, and it's a times f of x, where 0 is less than a, but a is also less than 1. And it shrinks the curve vertically by a factor of a. So, we need a number smaller than 1, which we already have, 1/5. And how does that affect f of x? Well, it's that number out front. So we want the number a to be multiplied by the number out front. Okay, so we're going to take g of x is going to equal, well, it's negative 5, but that's going to be multiplied by 1/5. And then we're going to have x. Okay, we want to change that. We want to shrink it by 1/5. Well, do simple math here. What's negative 5 times 1/5? 5's cancel. We're left with negative 1. So g of x equals negative x. Done. I'm going to erase these answers for more room. We're on number 7. We have the function f of x equals absolute value of x plus 3 plus 2. Now, we want a vertical stretch by a factor of 4. So vertical stretch right here, and our number goes out in front of the function. And so we have our function, we have to write a 4 out for that. So g of x equals 4 times the absolute value of x plus 3 plus 2. And I'll give you 1 second. Okay, I just wanted to double check, make sure we didn't mess up there. So we're good. There's our vertical stretch by a factor of 4. This next one, we have a horizontal stretch by a factor of 6. So let's go back to this cheat sheet. I want a horizontal stretch. Okay, okay, so this is a little backwards. The horizontal stretch only affects x. So horizontal only affects x. And a stretch is a number that is less than 1, in between 0 and 1. Okay? So, it only affects x. You want a horizontal factor by, oh, okay. Okay. Okay, I'm going to go back to this transformation. Look at this. Horizontal stretch is a number between 0 and 1. But they give us a horizontal stretch vector 6. And that's not a number less than 1. When you see horizontal stretch, horizontal shrink, we have to think of the reciprocal. Okay, horizontal stretch, horizontal shrink. We have to think reciprocal. Okay, what's the reciprocal? What is a reciprocal? Well, the reciprocal of 1/2, or let's do a better number. The reciprocal of, I'm just doing a random number, just any number. Just do a reciprocal of 3/4 is, just flip the fraction, 4/3. Okay, that's what a reciprocal is. Now, I want to take the reciprocal of 6, or 6/1. What's the reciprocal of 6/1? 1/6. That's the number we have to work with. And our horizontal stretch is the number multiplied to x. Well, we already have a 3x next to that. So we're going to have g of x equals 3 times 1/6 x minus 9. Hey, can we multiply 3 times 1/6? Well, it's g of x equals 3/6 minus 9. Simplify 3/6. Our final answer, we have to get rid of this reciprocal. Our final answer, g of x equals 1/2 x minus 9. That's our final answer. And number 9, horizontal shrink. Yeah, we have to think reciprocal, horizontal shrink. We need the reciprocal of 1/4. What's the reciprocal of that? 4/1, or just 4, right? So instead of x, we're going to have g of x equals negative, that doesn't change, 8 times 4 x minus 4. Okay, final answer, can simplify, g of x equals negative absolute value 32x minus 4. There's our final answer. Number 10, consider the function f of x equals the absolute value of x. Write a function g whose graph represents a reflection in the x-axis followed by a horizontal stretch. Okay, so this is multiple steps. I'm going to erase this, give us some more room. We're going to write a function g, so let's start with that. Our new function is going to be g of x. We want a reflection in the x-axis. So how does that look? A reflection, x-axis. Oh, it's a negative out front. Boom. Easy enough. So g of x is going to equal negative. Okay, so it's going to be negative. Followed by a horizontal stretch by a factor of 3. Horizontal stretch, what do we need to think of? Reciprocal. What's the reciprocal of 3/1? It's 1/3. So we're going to have negative 1/3 x. And a translation 5 units down. Translation 5 units down. Let's go here. 5 units down. Spin the word down. Down, minus k. That's it. So minus the 5 after everything, and we're done. Okay, number 11. Which of the transformations in section 1.2 will not change y-intercept? We're not going to do that one. That is a